Hello everyone, my name is Zach Cole and I'm enrolled in the Computer Animation Bachelor's Program at Full Sail University. Today I will be doing a physics experiment for my November 2010 Fundamentals of Physics class. This is my first time doing a podcast, so please bear with me. The experiment I will be performing today I am going to call the contained vacuum, in which I will be inducing a natural vacuum into a plastic container. Before I proceed, I want to issue a word of caution. Do not try this at home. The experiment can be very dangerous if you do not know what you are doing, and before beginning any kind of experiment, it is vital to address safety issues. Please do not proceed with this experiment if you are not 110% comfortable, and if you are comfortable with this experiment, please follow all instructions outlined in this video. For this experiment, I will be using the following items. One plastic jug, doesn't have to be anything fancy. This is a 5-liter old water bottle. A paper towel, nothing fancy. Lamp oil can be lamp oil, butane, kerosene, anything but gasoline really. Box of matches, and plenty of water nearby in case something happens. So first and foremost, you want to make sure, in order for the experiment to work, that you have an airtight seal. So take your cap, screw it on all the way, squeeze. No air comes out, you're golden. Looks like we're good with this, so let's proceed. Next, you want to take your paper towel, fold it in half, fold it in half once more, and then one more time until you get something that resembles this. Then fold it once more and flare one of the ends out, like so. This way, when you put it in the bottle, it'll hold itself up so you have your hands free. Next thing you want to do is take your wick, soak the bottom portion of it in your accelerant. You don't want to add too much in there. You don't want the flame to get out of control. Just a touch is fine. I've already taken the liberty of doing that for this experiment to make things a little easier to keep within the time limit. So let's proceed. You want to take a paper towel, put it in the opening like so, and next step, before we light any matches, go wash your hands. If you've gotten any of the lamp oil on your hands while putting it on, which you probably did by accident and you didn't know, you want to wash it all off beforehand, because if your hand catches on fire, then it's not going to be very fun. So before I actually proceed with the experiment, I'm going to go over how I'm going to do this, because I'm going to need all my hands free. So I'm going to strike the match, pull this up like that, light the bottom, push it in. Once it goes in all the way, I'm going to seal the cap and we're going to watch physics in action. So let's begin. Cool, huh? So check it out. In a matter of seconds, the jug imploded in on itself, and the flames went out. Why is this? After the flames drop into the plastic jug and the cap is screwed on tightly, it creates an airtight seal with a finite amount of air inside. Fire feeds off the air, using it all up, and goes completely out once the air supply has been depleted. This is where Newton's third law comes into effect. The law states that for every action there is an equal and opposite reaction. When the air is sucked out of the bottle, it creates a vacuum because of air pressure inside is trying to equalize with the air pressure on the outside. Since there is no air on the inside of the jug, the outside air pressure pushes harder on the outside of the jug in order to match the pressure on the inside. To prove that there is a vacuum inside the jug, you can simply open up the cap and watch as the air rushes out. So I don't know if you heard that or not, but the air just tried to equalize what's inside. And have you ever noticed that when you open a bottled beverage, it hisses or the cap pops, if you have that kind of cap, when you open it? This is because the beverages are poured into their containers hot and then sealed airtight. The heat burns up the remaining air in the container and it creates a vacuum. When the cap is open, the air rushes back into the container. This is also proof that there's a correlation between heat and air. So now it is a bit easier to understand how a vacuum works within Earth's atmosphere. Once again, my name is Zach. Thanks for watching.